Welcome to this lesson where we are going to talk about ratios in similar polygons. Figures that are similar, this little squiggly line represents a symbol for similar, are figures that have the same shape but not necessarily the same size. If we look at example on the left, triangle 1 is similar to triangle 2. They are the same shape, but looks like triangle 2 is a little bit bigger. And an example of not similar polygons, or triangles in this case, triangle 1 is not going to be similar to triangle 3 because they are not the same shape. Triangle 3 looks more like a right triangle. It has a right angle there, whereas triangle 1 doesn't look the same at all. So they will be the same shape, but not the same size. In order for two polygons to be similar, the corresponding angles have to be congruent, and the corresponding side lengths have to be proportional. So in this example, we have a quadrilateral, two quadrilaterals, where all the corresponding angles are congruent and the ratios are proportionate. So for example, AB over EF, so AB is 6 and the side length of EF is 12, which reduces to 1/2. If you double check BC over FG, so BC 5.4 over FG, which is 10.8, that would also equal 1/2. You could double check the next two, but all of them have to have the exact same ratio, and they do, of 1/2 for the polygons to be similar. So here's an example. It says identify the pairs of congruent angles and corresponding sides. So the angles that are corresponding, that are congruent, I see this angle, angle R, and angle Z. They both have one tick mark, one arc. So I would say angle R is congruent to angle Z. The next angle is the one with two arcs. That would be angle Q is congruent to angle Y. And when we have two angles of a triangle congruent, our third angles theorem tells us that the third angle is congruent. So angle S is congruent to angle X. Now we need to check to see if the corresponding sides are proportional. I'm going to check this side. So XY corresponds with SQ. We have 6 over 9, which would reduce to 2 over 3. The next side that we would match up would be XZ over SR. And that would be 9 over 13.5, which if you use your calculator to do 9 divided by 13.5, you would get 0.666 repeating, which is, if you turned it into a fraction, 2 over 3. And our last side, QR, lines up with YZ. QR over YZ, we would have 12 over 18. If we divide them both by 6, we'd end up with 2 over 3. So because all of the sides are proportional, they have the same ratio, we can say that these two triangles are similar. And that's the symbol that we would use to describe similar. A similarity ratio is the ratio of the lengths of the corresponding sides of two similar polygons. The similarity ratio of triangle ABC to triangle DEF is 3/6 or 1/2. We get that by comparing the side lengths. So for example, if we compared AB to DE, that would be 3/6, which is where we get our 1/2. But if we go the other direction, we go from triangle DEF to triangle ABC, we flip-flop the numbers, 6/3, or a ratio of 2. So it's important to know which triangle you're mapping to which triangle to figure out your similarity ratio. Example 2 says determine whether the polygons are similar. If so, write the similarity ratio and similarity statement. These are both rectangles. And since they're rectangles, we know that the angles are equal. So angle P is congruent to angle T, angle U, I'll go with angle Q is congruent to angle U, angle R congruent to angle V, angle S congruent to angle W. Now we want to check to see if our sides are proportional. So PS lines up with TW. So if we check the ratio, it'd be 4/6, which would reduce to 2/3. PQ corresponds with TU. So if we check 12/16, if we reduce 12/16, we divide them both by 4, we'd be left with 3/4. These two ratios are not the same. So these polygons are not similar. Okay, this example says determine whether the polygons are similar. If so, write the similarity ratio and the similarity statement. Well, we know that angle A is congruent to angle D, angle B congruent to angle E, which leads us that angle C is going to be congruent to angle F. Now let's check the sides. So the smallest sides, DF and CA, we can check. So 12/16 would reduce to 3/4. AB corresponds with ED, so 15/20. That also would reduce to 3/4. We got side EF corresponds to BC, so 18/24, which is 3/4. So all three sides are proportional. So our similarity ratio is 3/4. And our similarity statement is saying that triangle ABC is similar to triangle DEF. Last example, it says a rail box car can be used to transport auto parts. If the length of the actual boxcar is 50 feet, find the width of the actual boxcar to the nearest tenth of a foot. It says let X be the width of the actual boxcar in feet. The rectangular model of a boxcar is similar to the rectangular boxcar, so the corresponding lengths are proportional. So if we have a model that is 2 inches and 7 inches, we know that it's going to relate to the actual boxcar, which is 50 feet in length, and the width is what is unknown. So the first thing I want to do is I want to convert this feet into inches. So if we go 50 times 12, that leaves us with 600 inches. We want to set up a proportion. So we know that the widths, x over 2, are going to line up with our lengths, which we can set up 50. We can use the 50 feet over 7 inches. And if we do our cross multiplying, we get 7x equals 100. Divide by 7 on both sides, and we get x equals about 14.3 feet.